All right, so we're looking at question number 5 from the week 3 assignment. So I don't know if you noticed in general, but the week 3 assignment can be pretty challenging because it involves a lot more math than the previous sections, and you'll notice that this is really going to be the section that involves the most work done by hand, or that you'll have to do the most calculations. This will actually, yeah, it'll be more than even the later chapters, so don't feel too bad about that if you find this challenging. Okay, so anyways, for this problem, we're dealing with a multiple choice exam. There are 5 questions and 4 choices for each question. So from this, you should be able to notice that this may be a binomial distribution because we have a fixed number of questions, n equals 5 questions, and there's only one correct choice out of 4. So if we're randomly guessing, it says right here, randomly guessing the answers, what is the probability? Okay, then we're going to find some probabilities. So randomly guessing the answers, that tells you that there's a 25% chance we'll get it right, the one correct answer, or a 75% chance we'll get it wrong. So so essentially what we're dealing with here is a binomial distribution. Binomial distribution with n equals 5, and we have a p equals 0.25 if we're considering the probability of getting the correct answer and not the probability of getting the wrong answer. Okay, so the first question is a little more challenging actually than this, the second and third. Part B and Part C. So Part B and Part C, I'm not going to address too much. I want you to think about that on your own because it's just Part B and C are pretty typical binomial distribution questions. What's the probability she gets all questions right? Okay, well, what would X be? What would be the number of successes? So, so in this case, I'll just tell you for Part B, we are going to be using the binom PDF function. PDF, because PDF is used when you want exactly some value. So we want exactly all questions right. So I'll let you try that. On your own. Part C involves at least. So I actually just made a video on a problem about at least for problem 2, C. So anyways, I've already gone over something involving at least one question right, but you will be using binom CDF. And remember, at least one question right is you can actually think of this as remember, CDF involves less than or equal to. At least is greater than or equal to. So you're going to have to kind of fiddle with the problem a little bit to be able to get it to less than or equal to. So the video on using the binomial distribution with a TI graphing calculator explains how to do this. So you may want to review that, but you will be using binomial CDF in some way. I'll just let you know that. But Part A is what I really want to discuss because this is a bit challenging, and you're not actually going to be using, at least the way I do it, I don't use a binomial distribution. You can actually you just want to use probabilities of success and failure to approach this. It's not really a binomial distribution problem for this one. So we want to determine the first question she gets right is question number 3. So that tells you question 1 is wrong. So, and then question 2 is wrong. And then question 3 is get it correct. Let's just put a check mark. I don't want to write it out. So we can determine the probabilities of each individual part. So the probability of getting it wrong the first time is 0.75. Because there's 3 options and of wrong and 1 option of right. So that's the chance of getting it wrong. And then similarly, second question, 0.75. And then question 3, getting it correct, 0.25. And then each of these trials are independent of each other. So there's an independent property that if you wanted to determine, well, actually a binomial distribution, you're dealing with independent trials. But either way, since these are independent trials, you want to multiply these together, each outcome together. So we're just going to take 0.75, multiply by 0.75, and then multiply that by 0.25. And that gives us the result for A. So hopefully that makes sense, just my thought process and the way I approach this. Hopefully you can visualize it and see where I got part A, how I got this result. A lot of probability problems in chapter 2, the week 3 assignment. You have to use this sort of thought process on occasions. But you really should familiarize yourself with the binomial distribution, the normal distribution, and know, and the first step is being able to identify which distribution you have in a problem. And I was able to see, I mean, I'm pretty familiar with this, these type of problems, so I was able to see it with the binomial distribution pretty quickly. But identifying a fixed number of trials and the probability of each outcome is the same. And so anyways, being able to recognize the distribution is one of the first things you want to see. And that will help, obviously, to get the right result. So let me know if you have any concerns, and I'll be more than happy to help. All right, thanks.